This conference will now be recorded.
So welcome everyone to the latest in the SCLF webinars, and I'm delighted to welcome Keith Torrance today from the University of Strathclyde to provide a talk on the impact of mining on land condition. Keith has been involved in the forum for a very long time and is a research associate at the University of Strathclyde. And he's currently investigating the beneficial reuse of dredged canal sediment, so hopefully we might get a second one from him at some point in the future when that's a bit further on, that research. He's previously worked as a geologist and environmental consultant, and excitingly spent 10 years in Alaska working on mining and contaminated site projects. His PhD thesis investigated pollution and mining speciation at abandoned mines in North America, Colombia and Scotland. So we're delighted to have Keith here today, and without further ado, I will hand you over to Keith.
Great. Thank you, Alison, and thank you to the Scottish Contaminated Land Forum for the opportunity to make this presentation. I've listened into most of the presentations in this series and found them very informative and detailed. For this talk, I want to give more of a general overview of some of the potential impacts of mining on land conditions. And maybe, as this is a huge topic, maybe just dig into one or two areas that I've had some involvement in or interest in. Great. So just, Alison's given an introduction, a brief biography of me. My interest in mining goes really back to my first job out of university, where I worked for British Gas on coal gasification, which looked like being the way to go in the mid-80s as we were running out of resources. And of course, North Sea gas came online and that suddenly became less important. But I have, been involved in some other mining-related projects. Most recently in Alaska, I worked on the geochemical baseline studies prior to permitting for a large copper mine. So that, of course, the idea being that if a mine is properly developed and engineered, then there will be no requirement for remediation in the future. So this is the brief outline of my presentation. I want to give just a very quick overview, then jump into some of the sedimentary type mining, which of course would include coal, which is of great relevance in Scotland, and maybe focus a little on some of the geotechnical impacts of coal mining in Scotland. As a little diversion, we're going to take a look at burning bings, and then jump down into metal mining in Scotland, or historical metal mining and their legacy, and some of the environmental impacts that are associated with metal mining. So this slide really just summarizes very succinctly all the potential geotechnical and environmental impacts. I've really divided them into these two columns. For geotechnical, obviously, we have things like subsidence. We also have, other issues such as fault reactivation, which can affect sites, and finally some of the waste material, the engineering properties of bings and other waste tips. Jumping on to the environmental impacts, ground gas potential. I'm not really going to say very much about that because it's been covered in some other presentations, but I will talk about some of the impacts to groundwater, acid rock drainage, and impacts to surface water related primarily to metals mining. So jumping straight into coal mining, we all know that Scotland has a long history of coal mining, and as you can see from this map, most of the central belt of Scotland is underlain to some extent by coal measures and has historical mining there. We're going to lump coal mining really in with other extractions of ironstone, clays, and also limestone, which very often were carried out simultaneously in these mines, and the products would all have been used, for steel making and other industry that sprouted up in this area. So it's relatively easy to check if you're working on a site. It's relatively easy to check if there's been former mining on the site, and I would point you to the Coal Authority website. It has a great interactive map that allows you to home in on areas, and they're also very helpful. They can provide all types of mining reports and detailed examination of potential mining at a site. It wasn't until 1872, I believe, that mines were required to provide plans of their mine workings. So consequently, as a lot of mining happened before then, any of these sites are not going to be completely exhaustive, and there's always potential surprises if you are, at any site that's underlain by, in particular, shallow workings there. Just to home in, this is from that interactive map. This is Motherwell and Wishaw. You can see just the kind of density of mine entries in this site. Each of these little red crosses is a known mine entry, but I can guarantee that there are a lot more than that in this one area. The dark patches there the dark blue patches rather, are shallow mine workings. So you can see how how concentrated the mining activity was in this one area, and other areas of Scotland will have an equally high density of shallow workings in the area there. It used to be said that Wishaw was well known for having very shallow mine workings. It used to be said that the miners, as they would walk home through the tunnel, they would tap the roof under their house to let their wife know that to put the kettle on as they were coming home. Whether that's true or not, I don't know, but it's certainly true that the minings are significantly shallow in that one area. Okay, so when we're looking at coal mining and other shallow mining, we're typically looking at the geotechnical impacts in particular, and those can be divided into different forms of subsidence and different issues with various waste materials from that. So this is a significant problem. As you can see, that little clipping in there from the Evening Times, half of Glasgow homes at risk from mine workings. And this particular example in Jordan Hill, residents were being asked to fork out around 5,000 to repair some of the old mine workings in the area. Certainly, very much a current topic. You can see this is from 2019, this photo. You can see a large sinkhole that appeared in somebody's field in Midlothian. Obviously, if there's houses around that, that creates a significant hazard there. So, one of the obvious hazards is from abandoned shafts. I've got a couple of examples here. What can make this a particularly significant impact is that often these shafts were capped back in the 19th century. They would start throwing down a lot of wood, bits of trees, until those would stick in the shaft, and then they would cover it up by soil. And of course, that wood is eventually going to rot, and consequently the shaft is going to be reopened, often with tragic consequences. I'm sure you read about the lady in Galston that unfortunately fell down a mine shaft in 2008 and ultimately perished from that one incident. Sadly, fortunately, that's not a very common occurrence, but it does highlight the extreme risk that can be from these abandoned shafts. Some of the other ones, there's a picture there from Derbyshire. You can see there's just some, looks like some railway sleepers holding up or plugging that mine entry there. So it's not just, of course, in coal mining areas. This is some pictures of a 300-metre mine shaft that appeared in somebody's backyard in Cornwall in 2016. And you can see that's a well-engineered shaft there that obviously would be very difficult and expensive to properly plug after that incident there. And, you know, sometimes there can be, this example here is a crown hole collapse in chalk somewhere near Reading. And that could date back, I don't know for sure, but that could date back to Neolithic times, as it was quite common for sort of bell pits to be used to mine flints from the chalk. And obviously something like that is going to have very little record of, or no record of, but could be an unexpected consequence in certain areas. So coming from Lanarkshire, you can't really talk about subsidence without bringing up the infamous Hamilton Palace that used to stand by, you know, where the M74 is now in the Hamilton Low Parks. I think the only thing that remains there is the old mausoleum there. This structure, it was famously undermined by digging all the coal from underneath the palace, and ultimately had to be demolished in the 1920s. The cynics there might say that the upkeep of such a pile like that was more than the good Duke could afford, and he was quite happy to have an excuse to demolish it. But nevertheless, it's a good example that even some historic structures, you know, can be lost to coal mining. Some of the other illustrations, one is obviously quite modern. You can see that end house there is come off its foundation. More commonly, you might see these patterns of fractures in surrounding buildings where the foundations have become compromised from mining there. And you know, if you're ever doing any site investigations, it's certainly worth having a look around to see if there's any evidence of cracks in buildings that maybe have been repaired over the years that might give some indication that there is some shallow workings there. I really like this photo. It shows some areas where coal has been extracted, and above those areas, the roof of the mine has begun to cave in and subsequently exposed through some open cast mining. But it illustrates really how these voids can then migrate upwards through, you know, fairly considerable thicknesses of rock there, and ultimately could become an issue at the surface if there's buildings there. So, you know, when talking about subsidence, there's a couple of things that are going to be very important. You know, one is obviously the depth at which the workings occur. The second factor is also the style of mining that was used to extract the coal. In this slide, it's taken from a fairly recent paper by some of my colleagues in the department. It shows some of the shallow mining methods and that have been used over the year. The earliest form of mining was typically these bell pits that you can see in figure A, where a shaft was sunk to the seam and then they would excavate the coal out until such time as the workings began to collapse, hopefully by which time they had abandoned the workings. And you can still see evidence of these pits in some areas of Scotland. You tend to see little circular depressions next to little Colbings there. Moving on, Boredom Pillar and Stoop and Room were very prevalent throughout the 19th century. Just jump ahead here. This is again some workings that have been exposed during open cast mining, and you can see very well here how that method was used. The idea being that you would leave these pillars, the stoops of coal, to support the roof, and then the material beside the pillars was mined out and extracted. Obviously not a very efficient method. You can see that you can leave, maybe 40% of the coal still in the seam. Of course, the temptation was always to go back and maybe towards the end of the life of the mine start mining coal from the stoops, and obviously that would further weaken the structure there. You can also see too in that picture some of the spalling that's occurring around that one column in the left there. You can also see some evidence perhaps of water ingress and oxidation of the coal and the pyrite in the coal, which will again further weaken those workings, and depending on a number of factors, you would expect some collapse to occur in that. So again, some of my colleagues at Strathclyde have been looking at this in a little more detail and trying to model the actual collapse process that occurs in these type of workings. And I've taken this diagram from their paper there in Geothermics. One of their key findings is that the permeability of these workings is degraded over time, partly through spalling of the roof, partly through just intermittent inundation with groundwater, which leads to these deposition muds and altered breccias within these former voids. And ultimately, with some of the subsidence taken up by faulting, you can lose some of the permeability in these former workings. So they're not the hollow channels that you might expect. Why is that important? Well, there's a lot of interest in looking at local geothermal schemes using the water that has refilled these old workings, which tends to be at about 15, 16 degrees centigrade, and therefore is ideal for some kind of regional heating scheme using heat pumps. So there's quite a few projects ongoing in Glasgow at the moment, looking to see if this is going to be a viable replacement for burning fossil fuels for heating, which of course is one of the major challenges in going to a carbon neutral economy. So, beginning in the 20th century, a new method came into prominence. This was longwall mining. You can see in this picture here, which is suspiciously clean, I must say, how it works. You basically have a big cutting tool that runs along the seam with the roof supported by these hydraulic jacks there. One of the key features of this process of mining is that After the coal is extracted for maybe a couple of meters, the supports are moved forward, and the roof below that is allowed to collapse and cave in. So there's really no void as such left from the mining process, but that can still create some subsidence issues in the ground. Specifically, you can have more kind of widespread ground subsidence that can follow some shallow troughs or hollows, and also some of these tension fissures which can develop parallel to the working face, and this is a good example from Wales here. So this method really, it came into prominence because it could be very easily automated using some of the machinery that I showed in that slide. So, better suited to larger mines, particularly in Midlothian and Fife would have used these methods too. Great. So another kind of consideration is sometimes the effect that mining can have on existing faults, both normal and reverse faulting. I would direct you to this publication from the Geological Society, number 29, which has a number of very good papers looking at some of the geological hazards associated with mining there. Great. So changing gears, looking at some of the environmental impacts. I'm going to just go through these fairly quickly for coal mining. Ground gas, if we've mentioned, is a significant hazard, particularly in central Scotland, and there have been some well-documented incidents such as Gorebridge here. Primarily methane and carbon dioxide are the main culprits here, and there's some very detailed BS standards and other guidance on how to address and mitigate those hazards there. You may also see, not so much in Scotland, but radon could be an issue from some metalworking mining around Cornwall, where you've got large granitic bodies associated with the deposit. Surface water, again, I'll talk more about this when we look at some of the metal mining, but discharge from abandoned mines can be an issue here. And you can see this is clearly after a flood event where the mine workings have begun to been inundated and discharged into one of the local rivers there. So, and also, one of the areas I'm interested in is, Colbings, which are ubiquitous across the landscape of central Scotland. What interests them about, what I find particularly interesting is their propensity to begin to burn through self-combustion, spontaneous combustion there. This is an example, one project I worked on very briefly. It's a mine in South Lanarkshire, which around about 2011 began to smoulder and burn. What was interesting about this thing was that it had been in existence for about 80, 90 years. You can see that the vegetation has grown on top of the bin, some fairly large trees there, but a long time after the event it began to kind of smolder there. You can see that red line kind of shows the combustion front, and it did move from one end of the bin, along the axis of the bin to the end of the bin. leaving this kind of red burnt shale in its wake there. But it was a great opportunity to investigate this, make some measurements, and document the processes at work there. So essentially, the material, the unburnt material in the burn is very primarily of this kind of dark shale, carboniferous shale, together with a lot of the waste rock from the mining operations and some of the coal waste that was, sorted from the better quality of material. This would all have been put in this one heap. So you end up with something with a carbon content of roughly about 10%, which over time will slowly oxidize, and until at some point the heat builds up to the point where combustion is initiated. And it's a flameless combustion, so there's no flames, but rather like a cigarette being smoked down, this ashing process continues through the burn there, through the bin. And it can get fairly hot inside the pile. We did some infrared measurements and estimated, the temperatures to be in excess of 600, 700 degrees centigrade, and ultimately published some of the data in this volume here. One reason we were particularly interested in this at the time, and we worked with some colleagues from the University of Edinburgh, was that this is very analogous to the STAR process for remediation of sediments that are with high concentrations of oils and tars that's been developed for cleaning up some severely contaminated sites. So this was a great natural analogue to see that in operation. It's by no means a rare event. This is another bin not far from Shotts, which was also kind of burning at the same time. And some very interesting structures there. You can see some of the vents there and some of the minerals being deposited along these vents. Looks like there's some sulfur crystals there, and you would expect, given that the high sulfur content of some of these coal seams, that sulfur dioxide, even hydrogen sulfide, could be released during these burning processes. Great. So just kind of switching gear, I'd just like to finish off by looking at metal mining, which in Scotland is primarily a historical activity, with its peak in the 19th century. Consequently, it's restricted, to a number of fairly well-known areas, and I just wanted to kind of go through some of those, talk about some of the issues that might be present there. This kind of picture here is of the Warnock Head lead hills, which is probably the best known of these mining areas in Scotland. It was actually active until the late 1950s, but with a long history of largely underground working various lead and zinc veins in the hosting sediments there. There's also some gold found, primarily some alluvial gold, so nobody has ever been able to kind of find any of the source for that gold. But one of the consequences is all the tailings that are left around Warnock Head. You can see them there. This is the old photo with a fairly recent photo there, showing some of the large tailing piles, and the materials in that waste is obviously very high concentrations of lead and zinc, but also elements such as cadmium, which has affected some of the tailings pond and watersheds in the area. Another area with historical mining is Strontium Argyle, again primarily lead and zinc there. Some of the old workings are still fairly accessible there. But not just lead and zinc, this is another example. The very tip of Shetland on the island of Unst is host to some fairly significant chromite deposits which were mined from the 1820s until the end of the Second World War. These occurred as pods within some very ultramafic rock amorphilite sequences there. They're also enriched in platinum group elements in fairly reasonable concentrations, to the extent that they have been the target for exploration drilling at various points in time. Another one of my favorites is the Rassi iron ore mine, which was mined largely just during the First World War. These oolitic ironstones composed of siderite, chamosite, goethite were mined, in the wartime economy there. So these are, these types of deposits and mining activities are generally fairly small scale, but are fairly widely distributed throughout Scotland. So it's well to check if there are events or mining in any kind of local area there. It's generally fairly easy to track that down. Of course, in recent years, there's been some interest in gold mining in parts of Scotland around Tyndrum. This is a Conanish gold project, which I believe is just gone into production, albeit on a very small scale, and really selling product to people that specifically want to have Scottish gold. But there are other potential exploration targets. If you extend through the Dalradian into Ireland, there are several other fairly well advanced projects in Northern Ireland there. So who knows, maybe sometime in the future we might see some kind of mining boom in Scotland, but I think it's going to be on a very small scale indeed. So in looking at metal mining, one of the main concerns is water quality. And in this example, this is a former uranium mine. You can see the coloration of the water in these tailing piles would give you a good indication that there is some metal mobility there. This is a diagram that Paul Younger put together, just showing some of the different ways that water, groundwater, surface water can be impacted, by mining activities, and that can be really divided into the workings themselves, discharge, ongoing discharges from the workings, together with infiltration in tailings pile and discharge to surface waters. Of course, one of the issues is that when you put tunnels into rocks, exposing various sulfide-rich ore bodies, you are allowing oxygen to ingress and begin to oxidize the minerals that are present there. So another consideration too is the tailings themselves. Erosion of the tailings can often be a significant pathway to pollute water bodies, and that's exacerbated in some particularly lead zinc mining areas, because as you can see, there's very little vegetation has managed to recolonize these tailings, which are actually over 100 years old in this case. So anytime there's any rainfall events, and as you know, we're getting a lot more of those, erosion of the tailings is going to put a lot of sediment into the upper parts of the watershed and then downstream into reservoirs and potentially cause an issue for drinking water quality. So, you know, when we typically think about pH as being one of the major controls on metal mobility, you know, obviously the more acidic mine water is, then the more metals or the greater solubility are going to be for most metals, particularly things like copper, lead. But a lot of these metals are also fairly mobile at higher pHs. You can see zinc there, the solubility can bounce back up as the pH increases. Obviously, too, the oxidation reduction potential is a factor, as well as the amount of dissolved oxygen that's present in the water. Other metals, particularly arsenic, can be soluble really over, you know, much wider range of pH and, you know, circumneutral as well. So you don't have to have acidity to generate metal mobility, but if you do have acidity, then it's certainly going to be an issue. So the next few slides, I'm going to talk a little about acid rock drainage and how that impacts land quality. So you're probably all familiar with this. Most sulfidic ores and even coal contains significant quantities of iron pyrites, other sulfides, which upon exposure to water and oxygen, you know, initiate this reaction that generates acidity. You can see these 3H being generated in these reactions. So we end up with a product of these reactions that is this iron ochre, ferric hydroxide, sulfuric acid, and sulfuric acid there, which raises the acidity of the water and, you know, reinitiates the reaction there. So you don't have to have oxygen present, although it does help, because the Fe3 conserves an electron acceptor and, you know, keep initiating this reaction once it's started. You know, most licensed mines, of course, they go to great lengths to make sure that their discharges are, you know, meeting regulatory standards. But of course, a large sector of the mining is undertaken in countries where not so much the regulation, but certainly the enforcement of the regulations isn't as strict as it is in Europe or North America. And this is, I just wanted to share with you some pictures I took in Colombia in a mining district which had some large-scale mining, but also some artisanal mining, small gold mines that were operated on a small-scale basis, with the ores being processed in the town to remove the gold. And you can see some of the impacts from this type of mining. That first picture in the upper left-hand corner is one of the entables where the ore is processed, and you can see that dark blue stain from all the cyanide that's used to extract the gold from the crushed ore, and then, you know, just dumped out of the facility there. Needless to say, the water quality is far from pristine. You can see this fellow here doing some sluicing of some of the drainage from these entables, and you can get an idea of the amount of sediment that's still present in the water draining these mines. It's also very alkaline because sodium hydroxide is added to keep the pH very high and prevent the cyanide from disintegrating. So generally huge surface water impacts from this form of mining. Mercury is also an issue because mercury is still used to extract gold from the crushed ore there. All right, so just kind of finishing off with some other considerations here. The first one here is that if you dig a hole in the ground, somebody's going to use it to dump waste, and that's very true in Glasgow, where a lot of the clay pits that were, you know, dug in the 18th, 17th century were in the east end of Glasgow, and particularly were subsequently used to dump some of the chromate processing ore from the White Factory in Glasgow. So anytime you've got a site where there's been any form of mining, especially clay mining, you've also got to wonder whether, you know, it was used at some point as a landfill or to dump waste. Another consideration in the UK is that, you know, given the age of the metals mining in the 19th century, most, if not all, of these sites are often scheduled ancient monuments. So there are, you know, potential restrictions in doing any remediation or any work at all at these sites. Some of them, you know, are also SSSIs because of the unique landscape there. This is another slide from the Mid Wales old ore field here. And another thing is, of course, species. A lot of mine workings are home to protected bat species, so there may be some issues to consider if you are doing any remediation on these sites. All right, so finally I've just put together really a summary table with some of the different types of mining and some of the different types of impacts that could be a factor there. In particular, some of the soil contaminants associated with different types of mining there. I'll also leave you with some of the guidance, and there's a great amount of very well-written guidance available that you can use to guide your investigations on these sites. And just kind of put 3 of some of the ones I found there, but there are other ones that are equally helpful in doing that. Great, so that's pretty much all I have. Be happy to answer any questions that are on the chat line.
That's great, Keith. Thank you very much for that. That was brilliant. I'm just going to stop the recording now. That's okay.